Welcome back from spring break, guys. I'm sorry that I can't be with you. We had our child over spring break, and so I'm going to spend some time with my family for the week. I'll see you a week from today. The last thing I want to talk about before you take a quiz on Thursday is 11.2. And 11.2 is talks about the transformations of data. Before break, we talked about 11.1. We talked about scatter plots, not scatter plots, rather box and whiskers and stem and leaf plots to brush up your skills on that. And we also talked about normal distribution curves. The last thing we want to talk about is this transformations of data. What happens when we add numbers into data, or what happens when we go ahead and either multiply or divide data that currently exists? Is there a pattern? Is there a sequence? Is there a behavior that happens that we can go ahead and use going forward versus having to recalculate all the measures of central tendency and dispersion and not having to go and do that all over again all the time? Is there a skill or is there a behavior that we can see that we can use going forward? What I want you to do first is look at the 5 numbers in blue. The 5 numbers in blue are the weights of 5 people in pounds. I know at the end of the month, each person had lost 3 pounds. Now these 5 blue numbers are the numbers of the weights of the people before they lost the 3 pounds. What I want you to do right now is I want you to find the mean, median, mode, and range and standard deviation of these original weights. Mr. Bergstead or anybody in the class, feel free to come up to the computer and pause for a second while people do that. From my data, I think I get that the mean when I go ahead and add all 5 numbers together and divide by 5. I think my mean ends up to be 146. I believe my median ends up to be 142. I think my mode is 155. I believe my range is 17, and my standard deviation, remember I can go ahead and get that by using a calculator function, that one variable statistics in the stat edit or the stat edit part of your calculator. The standard deviation, when rounded, is at approximately 7.46. All of those 5 numbers are something I would expect that you can get relatively easily. What I want you to do is, I want you to predict how the mean, median, mode, range, and standard deviation will change when I incorporate the fact that I've lost the 3 pounds at each one of those. So I know we can go ahead and do this. I know we can go ahead and say, okay, 138 goes down to 135. I know 142 goes down to 139. I know the 155 goes down to 152. I know that the 140 goes down to 137, and again 155 goes down to 152. Okay, I know I can remake the same list, and I know I can go ahead and recalculate all 5 of those, but realistically, what should happen? If I look at those numbers, mean, median, mode, range, and standard deviation, what should happen? Okay, again, think about what could happen with those if all I did was simply took every one of those numbers and reduced them by 3. Now, let's go ahead and actually figure out what actually does happen. Okay, I want you to find the new mean, median, mode, range, and standard deviation after they lost the 3 pounds. Okay, so again, from that list in the middle where I reduced every one of those numbers by 3 pounds, I want you to find the new mean, median, mode, range, and standard deviation. Again, feel free to go ahead and hit pause on this video so that you can go ahead of time to do that. When I do this, I believe I get a mean of 143. I get a median of 139. I get a mode of 152. I get a range of 17, and I get a standard deviation of 7.46. Now, compare those numbers from above. You can see that the mean reduced by 3, the median reduced by 3, the mode reduced by 3, the range stayed the same, and the standard deviation stayed the same. That's not a coincidence. That's actually very, very helpful to us. What if we had thousands of pieces of data? The last thing I want to do is take every one of those thousands pieces of data and reduce them by 3 and recalculate them all. Instead, if I can see a pattern, which I already do, and saying, hey, if I'm simply reducing a number by 3, or on the flip side, if I add by 3, if I add or subtract any one of these numbers, as long as I do it to all of them, you can see that the mean, median, mode, and range, the mean, median, mode all stay the same, or all reduce, rather, not all stay the same, but reduce by a factor of whatever you reduced it by, in this case by 3 pounds. On the flip side, I can see that I have the range and standard deviation staying relatively the same. Okay, and so that's actually kind of a nice thing. So when general, okay, and I want you to write this down, in general, when you add a constant to data values, in this case, you say, well, Mr. Wall, I didn't add. Well, I really did. I subtracted 3, but we know that subtraction is the same as adding the opposite. So I really added a -3, added a constant value of -3. And so when I do that, and I'm right in the middle of the screen right now, it says when a constant is added to every value in the data set, and it's important that you know it's every value in the data set, the following are true. First of all, the mean, median, and mode of the new data set can be obtained by adding the same constant to the mean, median, and mode of the original data set. And so instead of taking all the numbers, decrease them by 3, and go through the whole process again of finding the mean, median, mode, and range, and standard deviation, whatever it is, we just know that for mean, median, and mode, we can simply reduce those numbers by 3 as well, as we saw on the previous screen. On the flip side, the range and standard deviation, the measure of dispersion, how far apart data is, remain unchanged. In our previous example, you would see that the range was still 17 and the standard deviation was still 7.46. Again, please pause this video to make sure you get these down. These are super, super important. The next logical question should be, okay, you can add or really subtract a constant value. All I'm doing to the mean, median, and mode is it simply adding or subtracting that same number. And for the range and standard deviation, I'm simply keeping them the same. But the next question for you should be, well, what if I multiply or divide by a number? What happens with that kind of data? So I want to go ahead and I want to use that same data. I want to go ahead and use the same numbers. So you can see here that I still have the same weights, the originals, 138, 142, 155, 140, and 155. But in this case, the doctor needs to convert the weight of the previous people to kilograms. Okay, so in this case, I want to go ahead and convert all these poundages, and I want to go ahead and convert them to kilograms. You can see the note there that a 0.45 kilogram equals 1 pound. And so what I need to do is figure out, okay, what do I need to do? Well, if I want to go ahead and convert them to kilograms, I want to go ahead and multiply by 0.45. So it's going to ask me again, give the mean, median, mode, range, standard deviation, the original weights. Well, I can cheat a little bit. We've already done that once. Okay, I already know that the mean for this one was 146. I already know that the median was 142. I know the mode was 155. I know the range was 17 and the standard deviation was 7.46. But then, okay, and we can predict, we can kind of go, okay, well, what might happen? When I want to multiply all these numbers by 0.45, the reason why I'm multiplying is because I want to get them to kilograms. And the way I get them to kilograms is multiply it by 45%. 45% of a pound would be a kilogram. Okay, what's going to happen? Well, let's just go ahead and figure it out. I want to find the new median, the new mode, the new mean, the new range, and the new standard deviation. So the first thing I'd probably do if I were you is I would convert them all. When I take 138 and I multiply it by 0.45, I think I get 62.1. Similarly, when I do multiply 142 by 0.45, I think I get 63.9. Similarly, when I do it to 155, I get 69.75. Continuing on, 140 would be converted to 63 kilograms, and then 155 again would be the same at 69.75 kilograms. I've taken all those numbers, I've reduced them down to kilograms. Okay, again, remember the magnitude of this problem. We're only doing 5. What if you had thousands of data, thousands of pieces of data? Okay, this is not going to be realistic that we're going to try and convert every single one of them and reconvert. We want to find a pattern of what's going to happen when I go ahead and do this to every single value in my data set. Now, once I have those numbers, what I want to do now is find the mean, median, mode, range, and standard deviation. So again, I'm going to give you a few seconds, take those 5 numbers, and I want you to find the new mean, median, mode, range, and standard deviation of the data set. Again, please pause the video if necessary. I believe when I do this, I get a mean of 65.7. I get a median of 63.9. I get a mode of 69.75. I get a range of 7.65. And I get a standard deviation of, actually I'm going to type that in right now just to make sure I get it right. 62.1, 63.9. I'm typing them into my stat edit right now, so hopefully you're doing the same if you haven't already. And when I do one variable statistics, I get a standard deviation of 3.36 roughly. Now, how do those numbers relate? They have no really record. They don't really have any obvious relationship to the originals. But what I want you to do is this: I want you to take 146 and I want you to multiply it by the factor of 45%, because that's how we got the numbers in the first place. It was 45% of a pound, okay, was a kilogram. So take 146, which is the original mean on the top of the screen, multiply it by 4.45. Not coincidentally, okay, you can see here that 146, okay, ends up to be 65.7 when I multiply it by that factor. Well, let's see if the median does the same thing. Take 142, the original median, and again multiply it by 45%. I get 63.9. Aha, this is working. Okay, if I do 155, which is the mode, and I want to multiply it by 45, okay, again, I get 69.75. Okay, this is pretty slick. These are all working. So I know if I take the mean, median, mode, and I multiply it by that conversion factor, in this case that 0.45, I end up with my new mean, median, and mode. Okay, now unlike when I added a constant, remember when I added a constant, the range and standard deviation, the measures of dispersion stay the same. Okay, in this case, it doesn't look like they obviously the same. So I want to see, does the range and standard deviation do the same thing? Do they actually go ahead and reduce by the same factor? So I'm going to take 17, the original range, and multiply it by 0.45. Sure enough, I get 17 to end up to be 7.65, exactly what the new range is. And then finally the 7.46, the standard deviation of the original data, if I multiply that by 0.45, I get, when rounded, approximately 3.36. So unlike when I add a constant, mean, median, mode, go ahead and reduce or add by the same constant, and range and standard deviation and range stay the same. In this one, if I multiply or consequently divide, okay, by a number in my data, all of the measures, all the statistics do exactly the same thing. So in general, go ahead and write this down. Again, it'd be important that you go ahead and pause the video at this point. Multiplying data values by a constant. When each value of a data set is multiplied by a positive constant, in this case we're multiplying by 0.45, the new mean, the new median, mode, range, and standard deviation, all of them, can be found by multiplying each original statistic by the same constant. So instead of us having to go through and change all the data numbers, recalculating all of them, what we now know is if we multiply by a number to every single one of the data set, we know that each one of those stats, mean, median, mode, range, and standard deviation, will also always reduce, okay, or expand by that same number. That's all I'm going to give you today. Your homework is 11.2, page 753, numbers 18 through 24, as well as I think you already did the Chicago Bulls worksheet, so you don't need to do that, but certainly do the 11.2 assignment for tonight.